Okay, class, good morning. So we come now to the second part of the topic in engineering economy, the uniform arithmetic gradient. So last time, we already discussed to you the principle involved in uniform arithmetic gradient. So by this time, I will give you an example so that in computing problems here, it could be easier for you. Okay? So let us now proceed to the example. So, given the cash flow diagram shown, if interest rate is 10%, determine the following. A. Equivalent total present worth. B. Equivalent total future worth. And C. Equivalent uniform payment for the uniform gradient only. Okay, so we have here, class, the cash flow diagram showing the payments from 2, which is 1,000. Another at 3, we have 1,500. And another is 2,000. Okay. So, for A, we are going to determine the total present worth, of course. So, actually, class, this is very easy. So, you can simply solve this problem using the equation of value. Okay? So, if you are going to determine the total present worth, just bring this all payments toward 0. So, and then sum it up, and then you will get the value of the present worth. But anyway, we have also some step-by-step solution for this. Okay, so in determining this payment or the total present worth, it could be P is equals to P sub 1 plus P sub 2. So what is this P sub 1 and P sub 2? P sub 1 represent the worth of uniform arithmetic gradient. So meaning this is the difference between the amount from the first payment to the second payment. So that is the gradient. So take note, class, that the gradient here is uniform. Okay? And P sub 2 represent the worth of the annuity. So meaning we have also an amount of the uniform payment A. Okay? So which is shown also in the second slide. Okay. So next, for P sub 1, we have the derived equation. So this equation was presented in the first part of the presentation of this topic. Okay? So we have here the derived P, or the present worth, is equals to G over I multiplied by 1 minus 1 plus I raised to negative N over I minus N over 1 plus I raised to N. So substituting now the gradient, which is 500. So the difference between the first payment and the second payment is 500, and also for the third and the second. Okay? So computing now the value of P sub 1, the value is 2,189.06. Okay. So let us now consider the amount of the uniform payment of 500. Okay? So, knowing now the formula for the ordinary annuity, for taking P, that is A multiplied by 1 plus I raised to N minus 1 all over 1 plus I raised to N multiplied by I. And then substituting the values, A is equals to 500, and then the amount now, or the present worth of the uniform payment of 500 is equals to 1,243.40. 42. So, summing up now, or getting the sum of P sub 1 and P sub 2, that is now equal to 319.45. Okay? So, take note, class, that the designation here in this equation, in the above equation, P sub 2 is equals to P sub 1 over 1 plus I raised to raised to 1 rather, is equivalent to the present worth of the amount at 1. So, and getting the amount of the annuity, of the uniform annuity, we consider it at 1. Okay? So, we consider 1 as the 0. So, we bring this 500 at 2, 3, and 4 to 1 to get the present amount, and then getting again the present amount to 0. So, that is P sub 2. So, do not misinterpret the designation of the parameters here. Okay? So, you disregard the other piece. So, you only consider this diagram in getting P2 and P1. Okay? So, that is now the present amount P sub 2 is 1,130.4. So, summing up, so that is 3,319.45. Okay? So, that is now the answer. Okay? So, let us take another, an alternate solution for this to make it easier maybe. Okay? So, alternate solution using the equation of value. Okay? So, where P now, P is the present amount of all the payments. Okay? At 0. Okay? So, that is now the present amount of 1,000 at 0.2 is equivalent to 826.45. And then the present amount of the second payment, which is 1,500, that is now equal to 1,126.97. And then getting again the present amount at 4 or of 2,000, that is equivalent to 1,366.06. And then getting up now getting the sum of the P sub 1, P sub 2, and P sub 3, the total now is 3,319.45, which is equal to the value at the previous solution. Okay? Equal 3,319.45. So, if you solve problems in uniform arithmetic gradient, you can also use an equation of value to make it easier. Okay? So, another, for letter B, so the equivalent future worth. Okay? So, this is very much easy. So, since the present amount was already known, and then get the value, or you bring the present amount to the future amount, or at 4 in the illustration. So, that is very easy. But anyway, we have also here the solution and getting the future amount. Okay? So, for f sub 1, that is g over I, multiplied by 1 plus I raised to n minus 1 over I minus n. And then getting now the f sub 1, that is 3,205. Okay? Next, for f sub 2, getting again the formula for the annuity, getting the future amount, that is substituting values. F sub 2 is 1,655. And then summing up now, F sub 1 and F sub 2, The answer is 4,860. Okay? So, take note class of the cash flow diagram also. Okay. Another solution. So, using again the equation of value. Okay? So, the future amount of these payments is equal to 2,000 plus f sub 1 plus f sub 2. Okay? So, take note that for compound interest, f is equals to p multiplied by 1 plus I raised to n. Okay? So, getting now the value of f sub 1. So, that is 1,500 multiplied by 1 plus 0.1 raised to 1. The answer is 1,650. And for f sub 2, that is 1,000 multiplied by 1 plus 0.1 raised to 2. F sub 2 is 1,210. Okay. Getting now the value of the total F, that is equal to 4,860, which is also equal to the previous solution, or F at the previous solution. Okay? So, the periodic payment now, or the equivalent periodic payment for the uniform gradient. Okay? So, we are referring to the equivalent uniform or payment. Okay? Equivalent uniform payment. From the formula, A is equals to G multiplied by 1 over I minus N over 1 plus I raised to N minus 1. Okay? Substituting values now. The value of the uniform or the equivalent periodic payment is equivalent to 690.58 pesos. Okay? Or 0.58. Thank you very much. So that ends my presentation class. Thank you very much.